So the second question related to the structure pop quiz 16. The compound T is an isomer C6NH12. Name the T. How we name a compound? We select the longest carbon chain and the numbering should start from a nearest double bond or a branch. So when we select, we can select this as a longest carbon chain, like 4 carbon. I can also select this as a longest carbon chain. I can get 4 carbon. I can select this as my longest carbon chain. I'll get 4 carbon. So anyway I select, I'll get maximum 4 carbon. So it means that any of the way I can select. Let's say I selected this way. This I selected at my longest carbon chain. Okay. Then the numbering should start from a nearest double bond. So if I count from here, I will have 1, 2, 3, 4. And if I count from other side, I will have 1, 2, 3, 4. So both ways, the double bond is coming at second. So I can say 1, 2, 3, 4. So these two which are not in my structure, like not in my main chain, we call them as a branches. So each branch contain one carbon. So it means these are the methyl branches. So which position we have the branches? Second and the third position we have the branches. So we'll say 2, 3 because second and third position. And we have two methyl branches. So we'll say di. Di means two. Meth because one carbon in each branch and yl because of a branch here, methyl. And 4 carbon atoms are there. So I'll call that as a bute because of 4 carbon. The double bond is with the second carbon. So I'll say 2 and then it will be in. So this is 2, 3, like second and the third position. We have two methyl groups. That's why we call dimethyl. Bute because of the 4 carbon atoms. And second position, we have a double bond. So that's why we call butene. So this is 2, 3 dimethyl butene. Then draw the skeletal formula. Draw the skeletal formula for structural isomer of a T. What is the meaning of the term structural isomer? Structural isomer can be a chain isomer, can be position isomer, or it can be functional group isomer. Like I can change the chain, I can change the position, and shows that it is a cis or a trans isomer. Like we want to make either, because this cannot be cis or trans, as you can clearly see that this identical groups are attached here with a carbon. So it cannot be cis or a trans as the identical groups are attached here. So what we will do, we can just make the same structure when we want to make the either a cis or a trans. And how many total carbon I have? If you see 1, 2, 3, 4, 5, 6 carbon atoms I have. So I want to just arrange 6 carbon atoms in a way that I can make the geometrical isomer. So if I draw like 4 in the same manner, so 4 in the same manner, and I need 2 more, so I can just draw here 1, 2, like 1, 2, 3, 4, 5, 6. So this is, and when we usually say, so this is one of them I drew. Which one is this? Because the heavy groups are attached on the same side, so this is a cis. And we want to make a structural isomer. So if we want to make a structural isomer, so we have to change the position also. Because structural isomers can be a chain isomer. It can be, why is the line in the middle not straight? No, because when we represent a double bond, when we represent a double bonds are there, so we draw the straight line so that it is easy to recognize that the heavy groups are on the same sides. If the heavy groups are on the opposite side, then it will be easy to recognize it's a trans. That's why for a double bond, it is always a straight line. How you make a skeletal formula? Look, this one, if I draw the displayed formula, what is this one? C double bonded with C. This is CH3, this is CH3, this is CH3, and this is also CH3. This is what the molecule, how it looks like. In the question, I want to draw the structural isomer. And that shows it's either a geometrical as well. Like, so what I simply do, what I simply do is I do C double bonded with C. I attach here, like instead of hydro CH3 here, I attach CH2 and I then attach CH3 and the hydrogen is there only. And this is hydrogen. Then I attach CH2 and CH3. But because they ask us to draw a skeletal, I am not supposed to draw this. I have to draw the skeletal. So how to draw a skeletal? Carbon-carbon double bond is there. With this carbon, two more carbon are attached. So one, two. With this carbon, two more are attached. One, two. And the hydrogen we don't show. So this is the same structure I drew here. So this is one of the structural isomer I drew, which is also geometrical. Is it clear? I can also change this. Like example, let's say I can draw in the same way. I can draw this. Yes, Ghulam, you have a question? Okay. So there's also another way to draw the same. So what I can do, I can draw like example, I have one, two, three, four. So this will be CH3, CH, double bonded with O. So CH2, CH2, CH3. So 1, 2, 3, 4, 5, 6. So I can just change this structure. Like I will have one carbon here and then one, two, like one is there, two, three, four. So it will be two, three, four. So one, two, three, four, five, six. That is another way. Or I can also draw the trans. If I want to draw a trans, I can just draw up. So it's the same idea. One, two, three, four, five, six carbon I need. The next is each carbon atom in T form a sigma bond, at least one with the other. As shown on the diagram, draw orbital that represent a pi bond that is also present in T. So we have to draw a pi bond. How we represent a pi bond in a structure? So pi bond is a region, like because bonding is actually representing a region where probability of finding electron is maximum. So when they say draw a sigma bond, will show a complete overlapping. But when there's a pi bond, electron can be above or below anywhere. So that's why we are drawing the two possibilities. That's how we are supposed to draw the pi bond here. State the hybridization of a two carbon atom between which a pi bond form. So whenever remember, if there's a carbon-carbon double bond, it is sp2 hybridization. If it's a carbon-carbon triple bond, it is sp3 sp hybridization. And if it's a carbon-carbon single bond, it is sp3 hybridization. So which hybridization happen or occur? It will be a sp2 hybridization. Next is a reaction scheme started with T shown a reaction to occur in the presence of a catalyst. The knowledge of the mechanism for this reaction is not required. Give a reagents and a condition for reaction 1. When alkene turn into diol, so what we need here for this reaction to happen, when double bond turn into diol, we need potassium manganate, cold dilute acidified potassium manganate 7. And as you can see here, this OH group turn into ketone. It gives an idea. This is oxidation also. So if we need an oxidation, we use oxidizing agent. Yeah, name of a reagent, we discussed that reaction of alkenes. Then state and explain how 2,4-dinitrophenyl hydrogen can be used to detect the presence of V as a product of a reaction 2. 2,4-dinitrophenyl hydrogen is actually a test for both the carbonyl group. Even a carbonyl group belongs to ketone. Even a carbonyl group belongs to aldehyde. So if you want to test an aldehyde or a ketone, we use this reaction or 2,4-dinitrophenyl hydrogen. And you have to learn what will be the observation. It will be a red precipitate, red or orange PPT is there if there is a carbonyl group is present in a compound. Like even it's an aldehyde or a ketone, it will give orange precipitate. So this is a test to check the presence of. So they ask, state and explain how 2,4-dinitrophenyl hydrogen can be used to detect the presence of a V as a product of a reaction 2. So presence of a V, because V contain a carbonyl group. So how we test a carbonyl group? So we use 2,4-dinitrophenyl hydrogen. The progress of a reaction 2 can be monitored by infrared spectroscopy. The OH absorption is always present because the water molecule is there as a solvent. Two absorptions and the bond responsible for these absorptions. So, and appearance will change during a reaction. So, how when we observe the reaction 2, OH, we cannot refer OH. Why we cannot refer OH? Because this reaction happen or occur in aqueous medium. So OH absorption will be common. Even this does not contain OH, but because the medium is water, so if a reaction happen in an aqueous medium, so when you start the reaction, the water molecules are there. When you end the reaction, the water molecules are still there. So the OH absorption will be there because of the water molecules. Now, what other than that we can distinguish that the bond absorptions has changed or will change? So you can see in this alcohol diol, there will be a CO bond like carbon with hydrogen. So in the beginning, there will be a CO bond absorption will be there because the reactants are there more. Even if you have one molecule of a product, the CO bond will also be there. C double bonded with O will be there. So what will happen when a reaction proceed, when a reaction happen or occur? So the CO bond absorption will turn into C double bonded with O bond absorption because that is what is the difference is there. So in the beginning, we'll have CO bond absorption because the reactant contain carbon oxygen bond. But as the reaction proceed, we'll have C double bonded with O absorption. So the infrared spectroscopy, we always check the difference between the bonds present. Then V is used in a wide range of organic solvent, range of organic reactions. Some reactions of a V are shown. So V is there, we add an alkaline or aqueous iodine. And then sodium, this is a reducing agent. Like and a ketone is converted into, if a ketone is there, it will be reduced into secondary alcohol. If it is aldehyde, it will be reduced into primary alcohol, aldehyde or a carboxylic. So reaction 4 is actually a reduction reaction. And what is reaction 3? Reaction 3 is actually a test to check the carbonyl methyl group next to carbonyl group. Like if any compound contain C double bonded with O and next to that is the methyl group. So this will always be a positive result. This is called iodoform reaction. Like when we use any alkaline like sodium hydroxide and iodine. So as you can see, this is a carbonyl group and next to carbonyl group is a methyl group. So if next to carbonyl, if there is a methyl group, this iodoform reaction will give a positive result. So it will form triiodomethane. And this triiodomethane will be a yellow PPT. So V and W are the colorless and soluble in water. State what you would observe in reaction 3. So what you will observe in reaction 3. So in reaction 3, as we know, alkaline and aqueous iodine, it is a triiodomethane reaction which will give a yellow PPT because of CH3, CHI3. So what we'll mention, we'll observe, will yellow precipitate or yellow PPT. Reaction 3 is a redox reaction. Identify the reactant. Identify which of the reactant is a which is reduced in this reaction. In reaction 3, so which of the reactant is, because in this case, because it is reacting with iodine, for V, when it react, oxygen is added. So if oxygen is added for a V, oxidation happen. So when it is reacting with iodine as well, iodine is also a reagent there. So iodine will be reduced to iodide ion. And in the question, we need which reactant is reduced in the reaction. So which reactant is reduced in this reaction? So iodine will be reduced because the aldehyde here, this ketone is being oxidized. Why we say it is being oxidized? Because oxygen is added. So if this substance is oxidized, the other reagent, aqueous alkaline, it's a medium. So iodine is the other reactant. So that's why the iodine is being reduced. Then construct an equation for a reaction 4. In a reaction 4, it's a reduction. As you can see here, there's a reduction. So you just have to count the carbon atoms like 1, 2, 3, 4, 5, 6 carbon atoms are there. How many hydrogen? According to that. So it is 1, 2, 3, 4, 5, 6 carbon, C6. This will have 3 hydrogen. 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 So C6, H12 and O. So the reactant is C6H12O, that is already written there, C6H12O. Plus, because it is reduced to alcohol, this is a compound, it is reduced. So what is the formula for product? So 1, 2, 3, 4, 5, 6 carbon atoms are there. So we say C6. How many hydrogen atoms are there? So 3 here, 3 here, 3 here. 3 here, 1 here, and 1 here. So this makes 14. So H14 and O. That's the for. So C6, H12 and O was a reactant and it becomes C6, H14 and O. So how many hydrogens are added? 2 hydrogens are added. And as I mentioned, if you use a reducing agent, the hydrogen, you don't write H2, you will write in a square bracket. So here 2 hydrogens are added. And as a result, here 2 hydrogens are added from by the reducing agent. It will become C2, C6, H14 and O. If you write, yeah, it's fine. If you write C6H13 and OH, that's also fine. Then X is a mixture of a 2 optical isomer. The optical isomers, how we draw the optical isomer is so we have to draw the 2 optical isomer. This is X. So first we identify the chiral carbon, which is a chiral carbon, which is having 4 different. So this is a chiral carbon because this will have hydrogen, OH, CH3 is there, and this whole group. So if you want to draw the optical isomer, so this carbon I will take, just draw 4 bonds. For this optical isomer is only for Cambridge students, not for Edexcel. They will study this. You will learn optical isomerism in A2, like drawing of the optical isomer. Concept is there, like you have to learn what is optical isomer, but not the drawing. And if I want to draw the mirror image, First, the best way, you just draw the two in this way, okay? And now just put the atoms. Anywhere you can put the atom. Like let's say hydrogen I'm putting at the top. So hydrogen is here, hydrogen is here. Then next to that is CH3. Anywhere, if CH3 is here, so then this will be CH3. Because these are the mirror images, so I'm making a mirror image. Next is OH. So if I'm putting OH here, so this will be OH. And then it is carbon with three methyl groups. So C with CH3, three of them. So CH3, 3, and C is there. So these are the two optical isomers. And both optical isomer of X can be dehydrated to form a single product. So for a dehydration, what we use, normal reagent is concentrated phosphoric acid, or sulfuric acid can be used, but remember phosphoric 6 acid H3PO4 concentrated as a dehydrating agent because it will work with all conditions. Then Y can form an additional polymer, addition polymer Z, draw repeat unit of Z. So we have Y. Look, if we what we do, we just simply flip this. If I flip this molecule, so this will be like C double bonded with, and there are, so I just flip the molecule carbon. Now, if I want to make a polymer, if I want to just draw a polymer, I can make a polymer in this manner that I remove this double bond. This is already there. So it is already there. I just have to put the branch link like, so this is a monomer, okay? Because a double bond is always a monomer. Why I flip? Because when I want to draw a polymer, I need a carbon-carbon double bond here. And like this is a monomer. If I want to draw a polymer, I'll just simply break a double bond and link them together and put a bracket right end. That will be a polymer. So why I flip this? So that I will have the carbon, because I want to make a polymer in the horizontal plane. Otherwise, I have to draw polymer in the vertical plane. I can draw that as well. But usually when we draw in a horizontal plane. So what I did, I flipped this molecule. So carbon-carbon double bond is there, and then these three. Now I want to draw a polymer. So the same structure I will draw, but without a double bond. And then link them together by N, put a bracket and write N. So this is the polymer. If N molecules of this combine to form a long chain compound. Is it clear? This one? You, as they did not mention either a skeletal formula of the polymer or a displayed one, so you can draw any of them. Then reaction 6 does not proceed quickly at a room temperature. Suggests a reason. Why is this so? Whenever you refer any reaction is slow, you always refer that as an activation energy. Like reaction, if any reaction does not proceed or happen or occur at a room temperature, so it's always the activation energy. So it will have a high activation energy. That's why the reaction does not proceed. When they said, yeah, I don't have to put a bracket and n. That's right. If they say repeat unit, then I just have to, I don't have to put n. If they say draw polymer, then I will put an n as well. Like in this case, as I only mentioned, draw one repeat unit. So I don't have to put n. I just have to, what I have to do is like this, I just first flip the molecule. Okay. And then I just break it. What I have to draw in exam is this. And then dotted line should be there, which shows that the continuation is there. Or You can draw a continuous line as well, but don't put N because they did not say draw polymer. They just said draw the repeat units, one repeat unit. So that's it. So this was a structure pop quiz 16. And next session we'll discuss the pop quiz 17.